So you want to store a file once, but reference it from multiple locations? Stick around to learn how hard and symbolic links can help accomplish this task.
You're watching IT Pro TV.
Hello, ladies and gentlemen. Thank you for tuning in to more of the LPIC 1 Linux Administrator Series. That's right, we're talking about hard and symbolic links. Don, what are some of the goals for this episode?
All right, so our primary task is going to be learning what the heck a hard and symbolic link are. So we'll talk about that. We'll learn how to differentiate between the two to know when one is appropriate versus another. We're also going to see how to use the ln command to actually be able to put all of this in place, as well as recognize links that are already present on our system.
All right, Don, so help me out. I'm just getting started here. What is a file link? What is it exactly?
Yeah, well, you know, in the teaser at the beginning, you described it really well. Occasionally, you might need to have a file that's referenced via more than one name or via more than one location, and file links facilitate that. Think of them as like shortcuts or aliases, pointers that indicate the location of a file that already exists, that you can already get to through one mechanism or another, but now you've got a shortcut to get to it.
All right, so that takes kind of care of like the what. Let's talk about the when. Use case. When would I use something like this?
So there's a few reasons, and you know, I guess I should clarify up front. You don't have to use file links ever. Like, you know, it is possible to not have them at all, but the odds are you do have them because almost every distro uses them in one form or another. But as far as scenarios, where you'll frequently see them used is when people are trying to obfuscate complexity, which is, those are gonna be my big words of the episode. So where they're basically just trying to make things look easier, right? You might have a really long file path and you hate having to type it, right? Like on some systems, when you pop in a DVD, it'll mount it to /run/user/dpossess/cd-rom or something crazy like that. It's now gonna navigate to this crazy folder structure every time. I might want to create a link to a /cd-rom folder. And now when I pop in that DVD, I can just browse to /cd-rom and I get there, right? That's a shortcut. It's much, much simpler. But you'll also see it with application developers where they create something that has multiple versions. And so they might want to name their binary with the version number on it, so you know exactly which version you're running. You see this with like Python and programming utilities. They do it a lot. Well, you don't want to have to reference a version number every time because every time you upgrade, the version number changes. You don't want to hard code that. So you might have an alias that's a more generic name. And you'll see that frequently, especially, we're going to do an episode on shared libraries later on and you'll really see it. Let me just show you an example here real quick on my system. So I'm on an Ubuntu 20.04 system, and I'm just going to jump over to like /usr/lib, which is a library folder. And if we take a look in there, if I just do an ls, right? I see a lot of different files in here, and notice that there's some that have very, very similar names. Here's libdeploypkg.so.0, and here's libdeploypkg.so.0.0.0. Okay, why does it have 3 zeros at the end? Well, this is the very first version of it, and if there's an update, maybe it becomes 0.0.1, or 0.2.1, or 1.2.3, or whatever. Well, it can do that. And this main one here, this light blue one, see how it's light blue versus the other is white? The light blue one is a link. And the link can always point to whatever special version it has. And so as a programmer, I can always do like hard points to this name, libguestlib.so.0, and know that it's a link pointing to the actual version of that library. And if I do an ls-l and get the long listing, we can actually see that a little bit better. If I scroll back up and find that libdeploypkg, see how it's got an arrow and then it's pointing to the longer name. They're just trying to hide that complexity and make it a little bit easier to be able to reference those files and make it where when we do updates, we don't have to go and change all of our source code or whatever.
So Don, I've seen before in like things like your bin folder and your sbin folder down at the root where you do an ls, maybe -lha, right? And it tells me that everything's pointing somewhere else. Can you help me out with that? What does that mean?
So in that scenario, it's being used for like backwards compatibility.
Oh, okay.
Right? So in the olden days, we had /bin, which was designed to have binaries that were required by the system to boot. And then you had /usr/bin, which were binaries that the rest of us would use, but weren't necessarily required to boot. There was a separation. It was part of the file system hierarchy standard. Well, over the years, people said, do we really need to have 2 separate folders? You know, most of this stuff isn't required to boot anymore anyway, like systemd takes care of most everything. And so it's kind of redundant. So many distros, and actually I can't remember if Ubuntu did, so we'll find out in a minute. Many distros said, you know what, we're not going to maintain 2 separate folders anymore. We're going to move everything from /bin into /usr/bin and just put it there, right? But the problem is you've got 50 years of Unix history of people going to the /bin folder, right? At the beginning of almost every script, you have a line that says !/bin/bash. People expect bash to be in /bin/bash. If I get rid of that, it's going to break all of those scripts. So here they're using links for backwards compatibility. If we go and take a look, I'm going to move into my root and do an ls-l, like Wes was describing, and I'm going to find /bin, and sure enough, see how /bin, one of the most important folders on your entire system, one that had critical binaries necessary to boot Linux, is now just a pointer, right? But it's a pointer to /usr/bin. And so if I go into /usr/bin, all those binaries that I used to have, like bash, that used to be in /bin/bash, are now there. So if I go into /bin and I look for bash in here, there it is, right? But it's not really there. If I go into /usr/bin and I do an ls bash, there it is, okay? It looks like I've got 2 copies of it on my hard drive, but I don't. I've only got 1 copy of it because /bin is simply a link to /usr/bin.
Now, Don, I can pretty much tell by the title of this episode here that there's hard and symbolic links. So I know there are different types of links, but these aren't the only names I've heard thrown around, and it gets a little confusing for me. Tell me about the different types of links.
All right, so there's hard links. Hard links are nice because you only have 1 name, right? Easy to remember, so hard links. A hard link is where you basically have an alias like we're seeing here, but it's pointing to the actual inode on the hard drive that stores that binary data, all right? As a result, hard links only work with files. They don't work with folders, directories, right? You have to think about the file system on your hard drive and how things are stored. File names and directory names are stored in the file system table. And then the binary data is stored out in the file system somewhere else on the hard drive. A hard link is an extra entry in the file system table that points directly to the raw data stored on the hard drive. So hard links have some limitations. They only work with files. They don't work with folders. And they only work if they're being created on the same file system. So in other words, if I have 2 hard drives, I can't create a hard link on one hard drive that points to a second hard drive. Or if I have 2 volumes on the same hard drive, I can't have a hard link on one volume that points to a file on a second volume. It has to be a hard link on one volume that points to a file in the same volume. So those are some of the limitations of hard links. Soft links are the other one. And you'll hear different names for them, like Wes mentioned. So soft links, symbolic links, there's a few other names that get bandied about, but soft link and symbolic link are kind of the most common ones. With symbolic links, these are different, all right? Instead of pointing to the raw data on the hard drive, they point to a path. They point to a folder, right? A directory path. So they're an entry in the file system table, just like a hard link is. But instead of pointing to raw data on the hard drive, they point to /usr/bin/bash or something like that. And because they're pointing to a path, they can actually point to directories, not just files. So soft links are a lot more flexible in what they can point to. Hard links are a lot more fixed. Hard links are more efficient, but soft links give you more functionality. So there's a bit of a choice we have to make when we go to create these.
Now, soft links seem like they're a little bit less restrictive, like you've mentioned. Hard links seem like that's something Wes could get himself in trouble with. A little bit more restrictive. Where would we potentially use something like a hard link, Don?
All right, so hard links are kind of neat in the way that they function because they are limited in how we can use them, right? But they're efficient. You're basically creating multiple copies of a file, but only storing one set of the data. Now, the neat thing about hard links is they're extremely resilient. With a soft link, it's pointing to a path, okay? So if I create a soft link that points to a file in another location, and I delete that file, the soft link is now broken because the file it points to is gone. Hard links aren't like that. With hard links, they point to the raw data on the hard drive. If I create 5 hard links on some raw data and I delete the original file, all the links still work. All the data is still there. In fact, the raw data of that file will stay until the last hard link is deleted. And in fact, if you really dig into the mechanical infrastructure of how this is all written in the file system, when you create a file, there's a hard link that's created for that file that's mapping the name to the file. So every file has one hard link on it. And then you can create more hard links if you want, and they'll survive a file being deleted, a file being moved or copied. Well, actually not copied, copy is different. But if you move it from one folder to another, that's fine, because it's just the folder that changes, not the raw data that changes. The exception would be if you went between volumes, right? That's where things start to break down. But as long as you're within a volume, that hard link will survive even if the original file is deleted, because the original pointer is deleted, not the original data. So really cool functionality there.
So Don, I'm sitting in front of a bash terminal right now, and I need to create me a link. What command or how would I go about doing that?
All right, so the links are actually pretty easy to create. So let me show you an example. So in my home directory, let's go into my documents folder. We've been working with some text documents. I've got the text for Dracula right here, and I've got it written just as Dracula with a lowercase d, but maybe I want to reference that with Bram Stoker's name. So I now know who the author is or whatever. But I don't want to store it twice. I do want to store it based on the book name, but I also want to store it based on the author's name. So I want to do this two different ways, right? Well, if I want to just get in and create a hard link, I can do that. I can say ln, and then I specify the target. The target in my case is dracula.txt, right? That's the target of this link. And then I give it a link name. And in my case, I'm going to make the link name Bram-Stoker-Dracula, like that, .txt. Okay, so now it's got the author's name. And when I press enter, I don't get any feedback, right? But if I do an ls and pull up the directory, I can see I have dracula.txt and I have bram-stoker-dracula.txt. If I do an ls-l and look at it, I can see them. Actually, let me add an H onto the end of that. And I can see that Bram-Stoker-Dracula.txt is 863K, and I can see that Dracula.txt is 863K. And notice how it's not light blue. The link I showed you earlier was light blue. These aren't. These are white. Okay, these are hard links. A hard link is actually tied to the raw data on the drive. So it has a file size. It doesn't show as being tied to the other one. I can actually delete Dracula.txt, and if I remove Dracula.txt and get rid of that, what happens to Bram Stoker? Well, when I take a look, it's still there. It's still 863K. And if I were to open it up, it's still there. I've got the text. I can go through and read it. I can see that Mel Brooks wrote it and left over from another episode. But I can see it right there because it was tied to the data, right? Hard links are kind of neat because they're hard to spot. When I pulled up that listing, there's an interesting column. Wes and I were talking about this the other day. There's this number here in the ls output that we don't pay much attention to. There's this number 1 right now. And what that's saying is that I've got this Bram Stoker file and it has 1 hard link on it. And so if I delete this file, it's the last copy. It's gone. I'm going to lose that data. But if I create another link, so I'm going to create a link to that Bram Stoker Dracula, and this one I'm just going to call dracula.txt again. All right. When I create that and I pull up my listing, notice that that number becomes a 2 over here. That means I've got 2 hard links to that file. And so if I delete this one, it'll still be around because I've got a second one somewhere else. But unlike a soft link, it doesn't tell me where that somewhere else is. It actually doesn't know. The links could be anywhere on this file system that are tied to that data. It's just got a record that, hey, there is another link to this, so it'll still be around if I delete it. So that's how hard links function. Right? But that's hard links. Soft links are a little bit different, right? It's the same command, right? So we use ln. In fact, here, let me go back. I'm going to get rid of the Bram Stoker Dracula so that we're back to just having dracula.txt. Now, when I made that link, the command I ran was, let me scroll back here, ln and the target was dracula.txt, and then bram-stoker-dracula.txt, right? If I just add a -s to that, it becomes a soft link. Okay, so when I do that, just the -s is the only change. Now I'm going to do the ls-lh again and take a look at it. I can see I've got Bram Stoker Dracula.txt. It's light blue. It's light blue, and it tells me exactly what it's pointing at. It's pointing at Dracula.txt, right? So I know what it's pointing at. And if I look at the links over here on the left, it doesn't count. It only shows 1 link. If I delete the original file, this link becomes broken. Or even if I just rename it, right? So if I move dracula.txt to dracula.txt.bak, so I'm going to make it kind of a backup. Now when I take a look at it, see how the link changed to red? The link is broken. It's broken. It doesn't work. The destination isn't there. A hard link would have survived that just fine. I could rename and move the other file. I could delete it. Doesn't matter, right? But with a soft link, they're very fragile. So they're more powerful, a lot more options, but a lot more fragile.
Don, so you said that hard links work with files, they don't work with directories. How would we accomplish a soft link, against a directory?
Oh, okay, sure. It's actually the same basic process, and it's actually a little more useful in my opinion. I just fixed the link while you were talking there, so I don't want to have a big red error on my screen the whole show. So, to link to a directory, right? Let's say, for example, well, I've got the Ubuntu installation DVD on my system, so it's plugged in, and by default, it ends up in a weird directory that I have a hard time remembering. It's /media, I think. Deposit. There it is. All right. So by default, when I pop that DVD into my system, it ends up in /media /deposit /Ubuntu 20.04 LTS AMD 64. That's a lot, right? So maybe I want to create a shortcut, a link to that, right? Not to a file on it, but to the directory itself. And so I decide that, hey, in my home folder, I want a link that points to this big, long folder. So I'm going to switch over to my home folder, and I'm going to say ln-s. So I'm creating a soft link. And I need to point to the directory. The directory in my case is /media /deposit /Ubuntu 20.04 and so on. And I'm using tab autocomplete because it'll automatically escape the spaces in that name. See how it's putting the / before the spaces? Kind of saves me a little bit of time. And then the destination, okay? I want this link to be /home /deposit, or I could have done / CD-ROM, right? Or we'll just do DVD, right? I want it to be called DVD. And so when I run that, again, I don't get a lot of feedback. And in my home folder, I now have a folder called DVD. And notice that it's light blue. So it's letting me know, I guess it's a little bit hard to see, but it is light blue right there. So it stands out from the other directories, and it is a link. And if I were to do an ls-lh, I could see that DVD points to /media /deposit /Ubuntu /whatever. But now I can just change into that DVD folder, and there it is. And if I print my working directory, if I do a pwd, see how it shows I'm in /home /deposit /DVD? I'm not. I've actually jumped over to the disk, but it's obfuscating that. It's hiding it. So I don't see the complexity of that folder. And now I can go in and access, I don't know, whatever it is that I want to access in here, all these different files. And so I'm in that DVD and I'm working. Now I do have to be a little bit careful with this, because what happens if I eject the DVD, right? So if I eject the DVD, that's no longer a valid path, right? So if I pull up a ls-lh, now it's a big red light. And if I try and change into that folder, I get no such file or directory. It can't get to the destination. But the moment I put that DVD back in, this link will light back up light blue again, and we're back in business. So a lot of people will use these to create simple aliases. Like, let's say you're a web developer, then you'll probably want to do something like ln-s/var/lib/http/html, right? Or www, or whatever it is that your folder is that you store your web pages, right? And you want to link that to your own folder so you can quickly and easily navigate in to be able to get in and work with web pages. So if that's something you frequently do, it's an easy way to make those aliases and save a little bit of time.
All right, ladies and gentlemen, that's a lot of great information on hard and symbolic links. Don, what are some of the key takeaways for our viewers here?
All right, so in this episode, we learned about hard links, which are pointers to actual raw data on the hard drive. We also learned about soft links, which are pointers to a path that we specify. We learned how hard links only work with files on the same volume, but soft links work with darn near anything, including files and directories. We also learned how to create them using the ln command. We didn't learn how to delete them, but oddly enough, you just delete them like regular files. Use the rm command, you can remove a link, and it leaves the original alone. So we learned about that. We also learned about what happens if you mess with the original. In the case of hard links, they were fine. In the case of soft or symbolic links, if you mess with the original, it breaks the link. All important things to understand when working with links in Linux.
All right, ladies and gentlemen, that's all for this episode, but we got a lot more exciting content coming up in LPIC 1, Linux Administrator, so stay tuned.
Thank you for watching IT Pro TV.